So, good evening to all of you. So, welcome back to my channel. So, today I am going to discuss about the basic means short note of not a basic short notes of organic chemistry reactions. It is I consider very selected reactions which is very useful for any competitive exams. And if you are means specialist of organic or physical and inorganic, so you have to little bit focus some selected reaction also in organic chemistry. So today I am going to discuss about these short revisions about organic chemistry reactions. So if you have not subscribed my channel, so please subscribe the channel and click the bell icon so that you can get the easily notification when I upload the videos, and share with your friends, like, comments. Okay, so I consider some selected reactions. First reaction is same and Smith carbon reaction. So what is this reaction? This reaction basically tells us about some form the cyclo products of alkene. So here the carbene react with these alkenes, so form the cyclopropane alkenes. So what is the reaction condition of this Siemens reaction? So first reaction is Siemens reaction. Siemens Smith carbene. So what Siemens Smith reaction tells? It tells about the when any alkene react with this CS2 and CS2I2 region in presence of this zinc copper metal, then it form this product. Okay, this is cyclopropanone of alkene. So if you see mechanism, so mechanism is first we have to form singlet carbene. So CS2I2 react with the zinc, it form the CH zinc iodide and iodine. So this bond will break, this goes like this, so you will get the singlet carbon. So this is the singlet. Now this singlet will react with this alkane, then you will get the product. So this is very important reaction, very easy, you have to remember. It is a concerted mechanism. It is concerted mechanism, and its stereochemistry of alkane should be maintained in the product. So if you have reactant cis, then product you will get cis, and you have trans reactant, then product you will get trans. Okay, so these are the things in semi-smooth carbene reactions. Okay, and there are so many applications. Please you go and see and solve the problem. So if you take one problem here, example, this benzene ring react this region, so you have to get this cyclic. So this react with this side. Okay, either you will get this also. So this one the minor, this will be the major. Okay, this will be the major product. Because here due to the stable of 3 degree carbocation form as a intermediate, that's why this is the major product. Now, so I think you people have understand what is the semi-smooth carbene reaction. So now we move to the other reaction which is very useful, like free radical substitution reaction with N-bromosuccinamide. Second reaction, free radical succinamide NBS. So this is basically NBS generate a free radical. So NBS is this. This is the NBS. So how they form the radical? It is basically form radical by following 3 steps. Okay, so let's first we see the application. If you have this molecule react with NBS, so only you have to keep in your mind, from this NBS you have 2 radicals. So this bromine will react with this position. Okay, this is the product. So basically in your reactant, one hydrogen radical remove and one is remaining on the carbon, and then another here bromine radical will combine with this position, then we will get the product. Okay, so this mechanism will go under this condition. Let's you have this okay. So you have this is hydrogen and you have this NBS and HBr. Okay, so we'll get this Br here, your bromine radical attack. Okay, so this is the product. So how we reach this product? So step 1, first this will form radical. Okay, and second step, this radical RO radical react with HBr, then you will get the bromine radical plus ROH. Third step, your molecules this will react with this bromine radical and you will get your product. Okay, this. So this is the way how to produce your product. So following these 3 steps you will reach to your product. Okay, hopefully you guys understand. Now we move to other reactions, which is before going to other reaction I will give one examples, or you can say note point. So if you have this react with NBS in presence of water, so your product will be like this. Okay, because of here 2 nucleophile use, then anti-addition will take place. Okay, so here basically the anti-addition happened in the reaction because 2 nucleophile is here. Okay, now I will give some notes points you have to remember. Second notes here, and another roles of NBS as a oxidation. Okay, this is also rules of oxidation. Alcohol oxidized to ketone. Okay, so some points here, third points this is now I move to next direction. Next direction is which one? Number this is the example. So this one 2, now 3 is benzene mechanism. So what is benzene mechanism? Benzene mechanism is basically undergo a strong base reagent. So if you have these molecules, here Cl, here H, and you have base, in the presence of base, and Na, NH2, in the presence of ammonia, then you will get the product this. Okay, but you will not get product this. Okay, you will not get product this, you will get this product, because if you see, you have base NaNH2. So what is the role of base? Base abstract proton, so it will abstract proton. So here you have proton, so this proton abstract this, so you will get this. Here you will get negative charge. Okay, and your chlorine will remove, so here you will get positive charge. Okay, so again this positive negative form a bond, so here you will get triple bond. Okay, so here your ammonia will react. NH2H. Okay, but it will not react this side. Okay, maybe form product, but not a major product. Major product form like this. So if we see example, you have this product, okay, and yoked to it is basically reduction. Okay, so you will get this. So okay, hopefully you guys understood three reaction benzene mechanism and free radicals succinamide and base. Okay, now we move to another reaction. Another reaction basically I will give notes points. I'm not going to in details, but you should remember this note as a notes. You have to remember as a notes. So reaction of cis to butane with bromine, you will get product like trio compound, okay, which is no plane of symmetry, okay, and but mirror image, it will form mirror image to each other, okay. It is basically from the racemic mixture. Okay, therefore it is optically active, okay. So this is the note. You have to remember these 2 points for in the reactions of cis to butane with bromine. So you will get 3 compounds which have no plane of symmetry and mirror image to each other, and it will give the racemic mixture. So note point 2, this is point 1, this is 2. So 2 points when your reaction of trans to butane react with bromine, then you will get just opposite of above. So you have considered here cis, here you have considered trans. So in trans it will get the retro product, okay. So you will get the just opposite of above, retro product, okay, and with plane of symmetry. And form the major compound, and it is optically inactive, just opposite of above, okay. So like this, if you have this trans ethylene react with this bromine, so you will get product like this, CSH H, you have bromine. Okay, here plane of symmetry, and similarly here also, if you in this condition, your both hydrogen will be above and this nature down, your product will be the 3O. Okay, so now we move to some types of addition reactions, which is directly you have to remember. Okay, so move to the types of addition reaction. So first we will discuss syn addition. Syn addition, under syn addition, let's say you have this alkene, so your osmonium tetroxide, if you have osmonium tetraoxide reagents, then product form under syn addition. So you have 2 OH react with this, your product will be like this. So I am saying here syn addition means both will be attacked, both will be added in the same side. Okay, so syn addition tells us about these things. So the second, when 1% of potassium per magnet, so here 2 OH also add in cis minor. Okay, in Wilkinson catalyst also, Wilkinson catalyst, rhodium PPH 3 का all thrice Cl. So here your hydrogen will attack in syn minor. Okay, means here the reduction will held undergo this reaction, both hydrogen will attack on double bond in same side. And fourth is hydroboration, oxidation, B2S6 THF. Okay, and S2O2. So here your H and OH will go, means attack from same side. Okay, and last woodward. Because water, so here your 2 mole of this OH will attack same side. Okay, so hopefully you finally you understand what I am trying to here say. So here means if you have this alkene and your your reaction condition is this, means you have you are adding these regions, so you will get the syn addition. Okay, so now we move to another things, anti-addition. So under this addition you will get this condition: bromine I2 Br2 nucleophile. So here Br nucleophile will attack and antiminor. Okay, and most important, oxymercuration. Oxymercuration demercuration. Okay, so here H, basically OH, will attack different sides. So your reagent will be here HgOCO CH3 का whole twice water, and second will be the NaBH का 4. Okay, so this is the things, types of addition, syn addition. In syn types of addition, there are 5 types, maybe more than 5 types, maybe, but I consider only 5 here. 5 types of addition, and anti-addition I have condition 3 types. Okay, so if you have this thing in your mind, you can directly apply and easily you can solve the problem. Okay, now if you see examples of this oxymercuration, demercuration, so if you have this, if you see example, if you have this, so if you have your reagent is this, so here the your product will be the, so sorry, here is the methyl. So methyl is the electron donating group, so electron moment from this side to this side. So here basically your H and OH is adding. So which manner? Anti-addition. So anti-addition means CH3 C single band CH2, and here your will create negative. So negative means your hydrogen will go here, and your OH will go there. Okay, so directly you will get the product. Okay, without any taking time. Okay, so this is the things. Now similarly, if you take the examples of this hydroboration oxidation reaction, so if you have similar product this, okay, and this electron move from here to here. So basically if you have this hydroboration oxidation, this condition, so in this condition your addition of HOH is inside, so your product will get inside, means your oxygen will get add here, your OH will add here, so we will get product like this. But this is incorrect, because this addition will undergo Markovnikov rule. So Markovnikov rule says that the negative part goes where the less numbers of hydrogen will be attached. So here your less numbers of hydrogen carbon, here 2 number of hydrogen goes, so negative part goes here, not here. So here you will get your OS will go and your hydrogen will go here. So this is, you have to mark star. Okay, so this reaction will undergo Markovnikov rules. Okay, right, hopefully you guys understood following what I am trying to explain you. Right, now we move to the another things. Another reaction means if you have any doubt, as I told, up to from starting to at this time, you can ask through your comments. Okay, now I will start, which is very important. Okay, epoxide ring. So here your reaction numbers 4. Okay, whatever, anyway, this is next reaction. As I told you, this is note points, so this is your, I think, 4th reaction, maybe, anyway, number doesn't matter. So 4, epoxide ring formation, epoxide ring formation. Okay, so this reaction undergo in the presence of paracid. So paracid, and here if your alkene is cis, then your product will give cis product. Okay, if trans, then give you the trans product. So like this. So if you see example, you have alkane and your per acid, okay, then form the product this, okay, directly. So now I am moved to the very important in every exam from this reaction there are a lot of questions they have, means examiner have been asked. So next reaction is surplus 5 surplus asymmetric epoxidation. Very important surplus asymmetric oxidation. So before we start to this reaction, we have to know about the reaction condition. So reaction condition, what is the reaction condition? So number first, in substrate, your substrate should be allylic 1 degree alcohol, okay, and reagent number 2, reagent det means diethyl tartrate or minus det. Minus det indicate SS and plus det indicate RR, okay, RR det. And third, dipped. If all these things in your reaction condition, then you can say your reaction is surplus asymmetric epoxidation reaction. So this is dip means diisopropyl tartrate, and fourth is Lewis acid. Lewis acid means titanium O isopropyl the whole 4, okay. So these are the main condition, okay. Temperature is 0 to 5 degrees centigrade. Solvent DCM, dichloromethane, and DBH 3 degree hydrogen peroxide, okay. So this is the reaction condition. If in your reactant have this reaction condition, reactant means your substrate is allylic 1 degree alcohol, undergo this reaction condition, then you can surely say your reaction is surplus asymmetric epoxidation. okay. Now we have to follow some trick. So trick, you should remember after solving, means before solving this problem, first you follow this trick, then you can solve the problem. If your this 1 degree alcohol, allylic alcohol is bottom right, means bottom right, okay. Then bottom right means if your 1 degree allylic alcohol bottom right as well as reaction condition is plus det, okay, plus R plus RR det, then your epoxidation will be below the plane, okay. If you have your minus det, means I am talking about the if your 1 degree allylic alcohols is bottom right, okay, then undergo this condition, your product will be the below the plane stereochemistry, means addition of this epoxide will be the below the plane. If minus det means plus SS, then your epoxide form as a measure above the plane, okay. If your allylic alcohol is bottom left, then what will happen? Which types of condition you have to follow? Follow means you have to see, means you should have plus det, then beta epoxide will form above the plane, okay. And the second condition just opposite of this, if you have minus det, then alpha epoxidation will be below the plane, okay, plane, right, okay. So if you take one example, then you can easily understood the problem. So you have these molecules, so if you see here, your 1 degree allylic alcohol is right side, okay. If you see from this is your bottom, this is your upside, okay, this is your right, this is your left, so your alcohol is the bottom right, you can say bottom right or top side right, okay. So right, so right means your reaction condition undergo RR det, So your product will be the below the plane. Okay, so your product will form below the plane. This is the product. Okay, if you have SS minus date, okay, and you have product like this, this is also bottom right, but you have minus date, so it will form the above the plane. Okay, so this form the above the plane. This will form the above the plane. So hopefully you guys understood surface epoxidation, surface asymmetric epoxidation reaction. Okay, okay, now move to the another things which is also very important. Reaction 6 Wolf Kirchner reduction. Okay, so what is Wolf Kirchner? You can first see, because video is going very lengthy, so I am trying to tell you in fast way. So your basically hydrogen will attach to this carbon after removing this oxygen. Okay, so basically your oxygen removed with 2 hydrogen of this base, product will form this. Okay, so this is the basic things of this Wolf-Kirchner reduction reaction. Okay, and similarly we can see next reaction, Clementine reaction. Clementine reduction. What is Clementine reduction? So here you have carbonyl and your reaction condition is zinc mercury concerned with under HCl, so your product will be like this also. Okay, so this is also Clementine reduction. Okay, and now I finally reached to cover all reactions, which is mostly very famous. Okay, Wetting reaction is not that much famous, that's why I am not advising you, but you can see. Okay, one more reaction I am going to tell you, which is very important, reaction. Okay, so what is Barton reaction? We have 5 minutes. So reaction number 8, Barton reaction. So this is very important. Okay, so Barton reaction says the alkyl group at delta position with respect to OH group converted into the CO group. Okay, so let's you have this. So you have OH here if you count here alpha, beta, gamma, delta. So delta is here. Okay, so alkyl group at delta position, you have alkyl group at delta position with respect to OH, yeah, right, converted into the CO group. Okay, so how this convert? This convert under NaCl under photolysis. Okay, this will convert like this. So this is the Barton reaction. Okay, so substrate is treated with NaCl followed by hydrolysis. Okay, followed by hydrolysis. Then you will get the product. So you can see the what is the mechanism. I'm not going to tell you the mechanism. Okay, so one more thing, this is also very important, as you can see as a notes. Tri and butyl tin hydride. I am going to about this. You can see as a notes, tri and butyl tin hydride. So this is your tri and butyl tin hydride. So what is role of this? So this role, what is the role? So I am saying roles. So you have this. In this reaction condition you will get this. So basically what is role of this tri and butyl tin hydride? It is basically form the radicals. Okay, so if you see, if you see step 1, you have Rx and you have this. First it form the radical. Okay, bu at, and this radical react here create radical. Okay, so BUSN X form. So basically here the role of this create the radicals. Okay, like, and then second step, this R radical react with this butyl SNH and form RH and butyl SN radical. So here you will get the RH. Okay, similarly the rule of here, basically you can directly attach with your, sorry, here is CX, this H attached to in place of X, any halogen. Okay, hopefully guys you understood what I am trying to explain to you. So okay, best of luck, and in next lecture I will I will give you another revision things. Okay, good night, bye bye. So please subscribe and like the channels. Okay, good night, bye bye.